Okay, so I've got a bar, it's steel, it's got allowable stress of 21 KSI. I want to find the maximum load so that it doesn't break. I've got two stress concentration here. I've got the little shoulder right there, as well as the hole. So I'm going to have to figure out for both of them as to what I'm going to do. And again, for both of them, K equals sigma max over sigma average, okay? Where sigma max, of course, is the 21 KSI, okay? So for each one, I'm going to have to find K and sigma average and then determine P. And then what I'm going to go with is whichever P is smallest is what I'm going to go with. So we'll start with the shoulder since we've got the graph up here right now. So for that one, I need R over H, okay, where R is the kind of the fillet, which would be 0.25. And then H is going to be the smaller one, which is the 1.25. So this is 0.2. The other thing I need is W over H to figure out this graph here. Okay, so to find W over H, I use W, which is the wider one. That's the 1.875. And then H is the same as it was before, 1.25. So for that one, I get 1.5. So from all of that, I should be able to find the K. Okay, so R over, I got to find my curve, which is W over H, so the 1.5 curve. So this is the curve that I'm looking at, okay? And I go to, let me see here, to 0.2, which means I'm right about there, okay? Which gives me a K of, I'll call it 1.725. Okay. So using that K, oh, I guess I also now need the sigma average for the shoulder. Okay. So again, sigma average is just P over HT. Again, that's shown right there. So P is what I'm looking for. HT, H is going to be, that is the 1.25 inches. And then T is the 0.125. So from that, I find that the sigma average, well, I guess I didn't actually find it, okay? But going back into my K equation, I go sigma, so I say 1.725. Again, sigma max is 21,000 PSI. Then I've got this whole thing here, P all over 1.25 times 0.125. Okay. From that, I can find P. So for just the shoulder, my P cannot exceed 1,902 pounds. Okay. So I'll have to do the same thing for that circle that I've got there. Okay. On that circle, I have to use this equation up here, which is 2R over W, and then I can find my K from that. Okay. So 2R over W on this guy, again, 2R is just the diameter, which is 0.75. Okay. W is 1.875. So that is 0.4. So using that and the equation from up above, I go to 0.4. You can see that is just a hair below 2.2. We'll call it 2.19 for K. Okay. For this one, I'm going to say sigma average, okay, is again P divided by, and again, for those who don't remember, the equation for that one is W minus D, where D is the diameter, times the thickness. Okay, so W, where the hole is 1.7 or 875 minus D, which is 0.75, and then the thickness on this is 0.125. Okay, so now I know sigma average, I know K, I can plug that into my equation. So 2.19 equals, 21,000. That's sigma max. And then that's over P divided by 1.875 minus 0.75, 0.125. So that big ugly equation, from that I can determine, for that one I find P equals 13. So this is the maximum P so that I don't have too much stress concentration at that circle. Okay, and this is the one I have to go with because it's smaller, right? I can't exceed that one, okay? Because if I go up to the 1900 of the other one, this one will have already exceeded its allowable force. So again, you go through, you find Q, you use, or I'm sorry, K, and you use that to find the maximum stress at the stress concentration using those charts.